Hello everyone, in this video tutorial I'll be talking about primes and sieve of Eratosthenes. So let's discuss what a prime is. So prime is a number which is divisible by 1 and itself. For example, 2, 3, 5, 7, 11, 13 and so on. One should note that 1 is not a prime number. So let's just start with a code that tells us if the number is prime or not. So we'll declare a function that will be bool type. Bool is prime. So it will take input n, and what will happen is that we will first assume it to be prime, and if we found any case that it's divisible by any number from 2 to n minus 1, then we can say that it's not prime because it has been divided. So for int we are starting from 2 because every number is divisible by 1. Alright, so I is less than n, so it will go till n minus 1 and I plus plus, and inside it, if that number n it leaves no if it has remainder 0, that means it is divisible by that, then we will do return false. All right, after the for loop, that means it was not divided by any number, then we will be returning true. So this is the function that will tell if the number is prime or not. Let's talk about time complexity. So this loop is running n times, and this comparison operator takes constant time, so it will take big O of n. So there is a better way, but for understanding that better way, we should take into consideration of factors. Say n is 36. So what are the factors of 36? 1 and 36. All right, 2 and 18 and 12. Sorry, right, and then 4 is 4 and 9. All right, 6 and 6. Then it will follow back the pattern 9 and 4. All right, and 12 and 3, 18 and 2, 36 and 1. So you can see that this pattern was repeated, right? For example, consider another number to be 25. So 1 and 25, it's not divisible by 2, 3, and it is divisible by 5 and 5, and then 25 and 1. So this pattern is getting repeated. So we don't have to necessarily check till n minus 1. We can just check till root n. Alright, because after 6 we know that pattern will repeat. After 5 we know that pattern will repeat. So we can, instead of looping through n, we can just change it to root n, and we can assign the equality here for the perfect square case also. So it will run till root n times, and the complexity will become root n, which is far more better. Say example, we have a processor of 1 gigahertz that computes operation in 10 raised to power 9 in 1 second. All right, so say consider we have 10 raised to power say 12 number, n is order of 10 raised to power 12. So by this big O of n will take time about 1000 seconds, that is approximately 17 minutes, and rate of root n will take up will 10 raised to power will be dividing it by 10 raised to power 9, and it will be root of it. All right, so 6 will be 9 minus 3 seconds. So you can take into consideration that it will take 0.001 seconds. 0.001 seconds. So it is very much faster than this. So now the another type of problem is that we have to print primes to get till n. So this is our objective for now. So the first method we can do is using trial division method. What this method tells about is that we will be taking numbers till n and we will check if it is prime or not, and if it is prime we will give the output. So it follows very easy a set of instruction, that is nothing but void prime till n. It will take integer as input. I will make a list, not necessarily a list, we can just output it also. For int I equals to, say I is less than equal to n, I plus plus, and inside this for loop, if, and we have created this is prime function here itself. So if is prime, we will be using this function. If is prime I, if I is prime, i.e. true, then it will see out it for a space, and yeah, that's pretty much it. So it for will close and loop will close. So this will give the output prime till n. So this loops run from n time for, and this has a complexity of root n. So overall time complexity becomes n root n, which is nothing but n to the power 3 by 2. All right, and now the next method is sieve of Eratosthenes. All right, so THENES, okay, whatever the spelling it is. So it's an initial algorithm in which we consider the number till n, and we consider them all to be prime, and then we remove the selected prime and all its multiple. We remove all the multiples of the selected prime. So we can write down that we assume to be prime, and then we remove all the multiple So let's just dive into the example for better understanding. Say n is equal to 20. So take the consideration of numbers from 0 to 20 itself. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. Alright. So the first one is that 0 and 1 are not prime. Okay, so these are removed. Alright, so now 2 is selected and all the multiple of 2 will be removed, that is 4, 6, 8, 10, 12, 14, 16, 18 and 20. So side by side I'll be noting down the number of total amount of number that we have to traverse. For 2 we traverse, including 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers are traversed. 10 numbers. Alright, so why I am noting down this, because it will come in handy for the derivation of time complexity of sieve of Eratosthenes. So now next prime number 3 is selected and all the multiple of 3 will be removed. 6 is already removed and 9 will be removed, 12 is already removed, 15 is removed, 18 is already removed. So we had to traverse through including 3, 6, 1, 2, 3, 4, 5, 6. So for 3, total number of number that we traversed is 6. And now the next prime 5 is selected, and now including 5, what the number will be removed? 10, 15, 20, they are already removed. So we traversed 1, 2, 3, 4. So for number 5 we traversed 4 numbers. Alright, so now the 7 will be selected. Now 7, 14 is already removed and 21 is out of the scope. Alright, so for 7 we, including the 2 7 itself, instead of 14, so 2 numbers are traversed. So coming down to the code of the sieve of Eratosthenes, so what we can do is that first we will declare array till n plus 1. Why n plus 1? Because we know that array contains the number from 0 to n minus 1 for the, if the array of size is n. So for number n to be included itself in the array, we declare the size of array to be n plus 1 so that the numbers are from 0 to n. Alright, so now we'll make prime 0 and prime 1 to be 0. What 0 essentially means is that not prime. So 1 and 0s are not prime. So this is nothing but that statement in programming language. And now we will be declaring for loop for int I equals to 0 equal to 2, because 1 and 2 are already considered here. I is less than equal to n and I plus plus. The rest of them will be 1, because that's the assumption. We assume all the numbers till n to be prime. Alright, that is essentially. Now comes the main part. For int I equals to 2, I is less than equal to n, I plus plus. We will be traversing through the array itself. We don't need to traverse to 0 and 1 because we already know that they are not prime. So if the number is prime, what we have to do is that we have to remove all the multiples of that number. What we can do is that we put the value 0 instead of 1 to the all multiples of I. So we have to add another loop inside of this. For int j equals to 2, j into I is less than equal to n j plus plus. What this loop does is that all the multiple of I for number I selected in this loop, 2i, 3i, 4i, 5i, all must be given value 0. But we don't have to go till infinite I, because if it's it should be under the limit of n itself. Alright, so that's why it's the limit. So 1i, 2i, 4i, 5i, ji, all should be put as 0. So inside this, prime of j into I will be 0. So that's pretty much it. So this loop ends here, this if loop ends here, and this for loops end here. So this is the sieve of Eratosthenes code. Now let's talk about the time complexity of time complexity. Now the statement written here will come in handy. For let's just take into consideration of the first loop, then it is running till n times. Alright, but those number are 2, 3, 4 sorry, pardon me, it's 2, 3, 5, 7, right? Because rest of them will not be running, because we'll have already subtracted them to put them to 0. So time complexity for if I is 2, so we traverse till 10 numbers. So 10 I can write it as n by 2. Keep in mind that n was 20. Alright, plus, and time complexity is the worst case. We take into consideration of big O of notation. So the for I equals to 3, we traverse 6 numbers. Alright, 6 is about n by 3. Alright, it is n by 3 is greater than 6, but we can take into we can consider 6 to be less than n by 3, and since the time complexity is worst case, so we can take write it as n by 3. And now for 5 it was 4 numbers, so that is nothing but n by 5. Alright, and for 7 it was 2 numbers, that is nothing but n by 7. So I hope you got the pattern till now, and it will go on. So it is nothing but summation of n by p, where p is less than equal to n and p is nothing but prime. Now to further get the simplified expression of time complexity of sieve of Eratosthenes, we have to take into consideration a few facts. Alright, these are facts. The first one is kth prime is approximately, it's not strictly equal to, but it's approximately equal to k ln k. Alright, so the first prime is obviously we all know that 2, but 1 into ln 1 will be 0, so it's not valid for all, but it is very much accurate for large value of k. So the second fact is that number of primes till m is approximately m over ln of m. So we'll be using these two facts to reduce the expression into much more comfortable expressions that we usually operate on. transcendental equation or trigonometric equation, but you get the larger point. So the time complexity now converts to summation of the n by p becomes n by p is nothing but pth prime. So instead of p I can write that k ln k, and now k goes from 1 to primes till n, and that is nothing but n ln n, n by ln n. All right. So but there is a problem here. For k equal to 1, the denominator becomes 0. So instead of writing this, we already know that the first prime is 2. So it is nothing but take 2 already here. So n by 2 plus summation of n upon k ln k, and summation will go from 2 to n upon ln n. We can take n as common from both sides, so it is nothing but n 1 by 2 plus summation of 1 by k ln k, k from 2 to n by ln n. All right. So there is a large number of possibility for very large n. So we can convert this summation from into integration, and it will go from 2 to n by ln n, and it will be dk by k ln k. Now let ln k equals to t. This implies 1 by k dk is dt. So the expression dk by k ln k converts to dt over t, and we all know that integration of dt over t is nothing but ln t, and what is t? T is nothing but ln k. So the answer becomes ln k, and we will be putting the limit because it's not it is the definite integration, not indefinite integration. So the expression becomes 1 by 2 plus ln k, where k will go from 2 to n by ln n. So expanding this, we get ln n by ln n minus ln 2. All right. So it's nothing but 1 by 2 plus, it was plus here, ln n minus ln n, using the property of log, minus ln 2. Now for very large n, the first one is constants are neglected. Second fact that I'm writing here is ln n will dominate ln n. So the following expression becomes, so this and this are constant, so they are neglected, and ln n will be dominating over this ln n. So it becomes ln of ln n. So overall it becomes the time complexity of big O of log n. So this is the time complexity of Sieve of Eratosthenes. So the trial division and sieve, the time complexity was big O of n raised to power 3 by 2, and it has time complexity of log n. So there is a huge difference between them. So that is why Sieve of Eratosthenes is very important algorithm for printing the prime number till n. Thank you for watching.